Welcome back to the Bioenergy course series. So, in the last class, we concluded with the parameters of any kind of biomass, what we are collecting from nature, what are the features what we have to look into, which include the moisture content, which includes the fixed carbon versus volatile matters. It includes the lignin to cellulose ratio, the concentration of alkaline elements present there, the ash content, and in between we talked in depth about each one of these parameters. So, today what we will be starting are the conversion technologies. So, when you talk about conversion technologies, the first thing what matter, what is the source of the biomass, and after that we take into, based on the parameters, suppose the source is say from aquatic plants, or say the source is from crop residues, or the source is some bio waste. Based on the source, we decide upon the conversion technologies. So, conversion technologies directly depends on the chemical nature of the biomass what you are obtaining, and the conversion technology further decides for what purpose that biofuel which will be developed will be used, whether it will have applications for automobile, whether it will have applications for generation of electricity through boilers, or it could be used for some other applications. So, essentially what does that mean? Depending on the requirement of the end user, the conversion technology takes its decision. Apart from it, the another factor which needed to be optimized in such operations is what is the cost for any such conversion. As we have already mentioned in the previous lecture, if your sample has higher water content, there are certain techniques which should not be done unless otherwise the water is being reduced, or if it has a higher lignin, then certain methodology will not be able to give you good fuel efficiency. So, now what we will do, we will enumerate the process, how we decide upon the conversion technologies, what are the parameters which are taken into account. Followed by that, we will enumerate the family of different conversion technologies, and then under those families we will be dealing with each one of those modules or processes which leads to different kind of solid fuel, liquid fuels, gaseous fuel, so on and so forth. And as we will proceed further, we will see how unusually important products could be derivatized from these kind of bioconversion routes. So, coming back to the slides. So, today we are starting with the conversion technologies. Okay. So, essentially it is, should add that biomass conversion technologies. Okay. So, this is the broad heading now we are getting into. So, if you just have a little recap where we started with the production of the biomass, where we talked about photosynthesis and all other processes. We talked about C3 plant, C4 plant. Then we talked about the biomass which is produced, what are the basic characteristics which just now I discussed, and now we are going for the conversion technologies. Okay. So, among the conversion technologies, what are the first step? The first step which is important out here is the source of the biomass. Okay. source of biomass. So, in terms of the source could be divided into 3 different categories. Category 1, which is, suppose you have a dedicated energy crops, you are growing dedicated energy crops, These could be different kind of grass, this kind of different kind of shrubs or herbs or even trees. Okay. Then the next is harvest you are obtaining from forest, obtained from forest lands, obtained from forest and other vegetation covers. So, this essentially does not mean that we are talking about deforestation. What we are talking about, there are many, say for example, dried leaves, trees in the forest are being trimmed, all those, or as you know, in many countries the rural people go inside the forest to collect, for burning. They do not cut the tree, only the twigs which over a period of time kind of dries and fall down, or they dries out, they break it and use it. So, that is what we meant by harvest obtained from the forest and other vegetation cover, which also includes, if you have to see, which also includes different kind of vegetable waste which are coming through. Okay. Say for example, you have a cauliflower. Okay. So, we generally use the floral part of the cauliflower, but the lower part we generally discard. So, that is also a form of a biomass. Similarly, whenever we are peeling, say potatoes, okay. So, most of the time we peel off the skin, that is a biomass. We are eating a banana, the peel, that is a biomass. We take an orange, we peel it, the rind of it, that is a biomass. Okay. So, these are all different form of biomass. There is a third form of biomass which now I am highlighting, which is basically biomass from waste, biomass waste in the form of sludge, okay. And this could be even the domestic waste, of course, of the biological origin. Okay. So, these are the different sources of biomass, and this is very important. Now, if you look at this list carefully, you will realize all the basics what we have covered as of now is encompassing this. Say for example, we have an energy crop. The first thing you have to understand, what is the cellulose to lignin ratio of that particular plant. Okay. Step 1. Then next thing what you have to understand, what is the water concentration at harvest. Third thing, does this plant grows with lot of silica from surrounding, or how much alkali metal percentage it has, how much fixed carbon it is having as compared to the volatile matters. Okay. So, all these have different numbers, and using Van Crevelen diagram you can place it exactly where it will stand. Okay. Now, phase 2 of it is that once we are done with this part, the phase 2, once you have decided upon it, is your conversion options at your disposal. Okay. Second thing is conversion options based on the properties of the biomass. That is what I was discussing with you, based on the properties of biomass. Okay. So, what are the different options we are having? So, before we get into the option, let me just, okay. So, I will continue with the point B, okay, which is out here. Okay. So, the key decisions before deciding the conversion efficiency. Okay. So, one of the key decisions what we have to take before we decide what kind of conversion route we are going to follow, this includes the type and the quantity of biomass feedstock. Okay. Biomass feedstock. Okay. What does that mean? So, that essentially means, first of all, type we have already discussed. What is the carbon, nitrogen, or carbon oxygen, carbon hydrogen, hydrogen carbon likewise. Okay. But in terms of the quantity, it is very important because we have to process them. So, we need some form of a reactor. So, reactor efficiency or reactor design is a direct function of what is the input you are putting into it. Like very small reactors may not be very efficient, again very large reactor may be very inefficient because you will be consuming a lot of energy in a large volume, but if your input is not good enough. Okay. So, for any kind of long term planning, you have to ensure your raw material, in this case is a biomass, that raw material is coming at a uniform rate. So, you have a reactor of a specific size. So, 365 days of a year, you know, every day this is on an average you are going to get an input and this will be the output. So, the whole planning of supply and demand and the conversion cost has to be worked out very right before we embark into any form of conversion technology which are available or which are at our disposal. So, that is why this particular point, first of all the type of the biomass and the quantity of the biomass feedstock is very, very important. The second is point 2, the key decisions is desired form of energy. What form or in what state you want the energy, desired form of energy. So, in terms of desired forms of energy, if we talk about the form word itself, so this could be divided into 3 different categories. Okay. The biomass could be divided into 3 different categories, out of which 2 falls under energy category, and the third one. So, if this is 1, this is 2 and this is 3, the third one falls under chemical feedstock. So, this is for the animals, okay, animal feed and all other stuff. In terms of the 2 categories what we are talking about, you could have either power or heat generation, mostly using combustion, which will be following up next, or you could transform into liquid or gaseous fuel in terms of transportation fluid. Okay. These are the desired form what we are talking about, and most importantly out here, this will further be worked out based on these 3 parameters, which includes end user requirement. Okay. This is very, very important, who is the end user. Second point is environmental standards. We will come with a case study on this one later, environmental standards, because whenever you are converting, there are several environmental issues which has to be taken into account. And the third thing is, the most important, is the economics. What is the cost benefit ratio of carrying out such transformation? What is the cost of the input? 1. What is the cost of the conversion? 2. And upon selling, what is the benefit you obtain? So, if the cost benefit ratio, cost versus benefit ratio is not favoring, then such technologies will not serve or will not survive the test of time. Okay? So, these are few points which one has to kept in mind while picking up or deciding upon what will be or what kind of conversion strategy one is going to follow. Okay? Now, follow up on that, once we talked about this, let me go back to the slide, and the next what we will be talking about is the third point, end user applications, which we have already mentioned. End user applications, and last one taking into account will be the infrastructure. This is exclusively and very importantly essential for countries like India, where infrastructure development is a big challenge. Okay? Infrastructure available. Okay. So, these are the points which one has to take into account while deciding upon what are the conversion technologies what we are going to dealt with. Now, from here, after giving you this brief outline, so let us again recap what I have talked. I talked about the source of the biomass, whether it is very dedicated and how uniform around the year, how it is all coming, like every day how much tonnage of biomass is arriving. Second, choice of conversion technology, which is based on the supply and demand of the biomass as well as the type of biomass. Third, we talked about the end users of the application and what would be the and what kind of applications in terms of quality, quantity and the type. Say for example, if we really need very high grade fuel, say for flying an airplane or a helicopter or something, then we need very fine grade, then maybe the conversion route may be totally different. You need low grade fuel, then the conversion could be a cheaper one. Then what form of conversion? Are we going for solid fuel, solid conversion? Are we going for liquid fuels, or are we going for gaseous fuel? Okay. So, these are the different parameters which will decide. So, next what we will do, we will move on to a new slide and we will talk about the, now we will put on a tabular form the different conversion technologies. Okay. So, coming back, so we have the biomass to, you are making energy out of biomass. So, here are the conversion routes. So, the conversion routes could be classified into three categories. The category 1 is thermochemical. Now, in depth we will talk about thermochemical, which I have mentioned several times earlier, and I told you that do not get worried, we will come back to this. Okay. Thermochemical is the most popular approach. The second one is biological or biochemical, biological slash biochemical, and the third one, which is not a very popular one though, is a mechanical extraction. Mechanical extraction, mechanical extraction process with process called, we will come in depth later, process called with esterification. So, one example I wanted to quote, rapeseed, since an oil seed, rapeseed methyl ester or RME biodiesel. So, there are other biodiesels also, this is just one example. Okay. We could talk about Jatropha and all those things, but at this stage we are not dealing with this. We will talk later about it. Okay. Now, in terms of the thermochemical category, it could be classified into 4 different groups, which starts with the most simplistic of all, called combustion. 1. Second one, that is pyrolysis. Pyrolysis is a technique of combustion in the absence of air. We will come soon onto that. Third one is gasification. And the fourth one is liquefaction, or this is also termed as hydrothermal upgrading. Okay. Hydrothermal upgrading. And we will talk about each one of these processes one by one. On the other hand, in terms of the biological route, which I am putting in green, we have 2 categories, 2 broad categories, and the broad categories includes digestion and fermentation. So, in digestion, one of the examples I am quoting here, production of biogas. This is a digestion process, production of biogas, which is basically a mixture of methane and carbon dioxide, methane plus CO2, whereas in the fermentation, the example is production of ethanol. Production of ethanol. As a matter of fact, fermentation route has been followed by mankind since time immemorial. Okay? Because most of the houses, if you look at most of these processes that across Europe and many other cold places in the world, you will see people have been making ethanol from wood, from other sources. So, this process of fermentation or ethanol production is a very old process. This is not something very new. So, as a matter of fact, if you think very rationally, biomass to conversion of different products which are inflammable product, mankind has been followed this for a long period of time. This is not something which has happened just very recently. Okay? Whereas, if you look at the digestion or the production of biogas, this is also a very not very, I mean, it is fairly old technique which has been followed. So, you have pit where the gases comes out, that is being used. Okay. Of course, now we are having very good biogas digesters and all those things, but it is fairly old. In Indian context, since my childhood, I have been seeing, at least I can say for last 40 years, there are a lot of biogas plants all over the place. So, in other words, if you think a little bit backward in time, if we talk about the sources of natural gases from where mankind has been drilling and taking up natural gases, possibly those are nothing, those are big dump yards of organic matters which over centuries have generated gas which must got trapped in the earth crust, where we have bored and slowly pulling the gas out and storing it for our day to day purpose. Now, what we are essentially, I repeated this again, I am repeating it. The challenge of bioenergy is that till this date, mankind has utilized the product made by nature or product which is developed in nature through centuries and billionaires, like coal, petrol, natural gas, all these, or even nuclear fuel, these have been gifted to man through centuries. But then when we talk about bioenergy, we are talking about a totally different thing. We are talking about now man wants to develop the raw material from which mankind is going to derive its energy. So, in other words, the raw material which nature has made in the form of coal, in the form of petrol, in the form of natural gas streams, now we want to mimic it and produce it in a controlled environment, which by far, if we look at the history of mankind as a whole, by far probably one of the most challenging vision, because what nature has done in billions of years, we wanted to do it in a short span. So, that brings us with this is a very philosophically one has to think over it, that over centuries organic matter transformed, went through a whole range of geological changes under heavy pressure, high temperature, transformed into something called coal. Now, having said this, that we are really at a challenging cluster of time, that means we really had to dedicate a lot of research into this area, how such conversions can be done in a controlled environment. It is not an easy task. It is gigantically tricky and tough to even to think in that angle that we want to transform them. So, if we see the field, it is moving slowly because it has every reason, because nature itself has transformed things over centuries, and here we wanted to do in the lab. So, with this background about what all the possibilities what we are having in this chart, if we come back to the chart again, just let us go through this chart once again with you. So, you have the thermochemical route, you have the biological or the biochemical route, you have the mechanical extraction process which will be coming fairly late, and within the thermochemical route you have the combustion, pyrolysis, gasification, liquefaction, whereas in the biochemical route you have the digestion, you have fermentation. So, what we will do now, we will take one by one each one of them and we will elaborate further. Okay. So, I will close in here. Next class we will be starting in the thermochemical route of combustion. Thank you.